Welcome to solverfy.
So here, for part A, from equation 35, we know that the voltage is going to be directly proportional to inductance. We know that this is similar to resistors, where the voltage is also directly proportional to the resistance. Now, here, the independent voltages for parallel elements are equal. So we can say V1 equals V2, and the currents are going to simply add. So we have I sub 1 T plus I sub 2 T. This would equal the total current I of T. Now, I say of T because currents are usually functions of time, and then we essentially arrive to the equation 2721 for resistors. Essentially, this means that here, the change in the current sub I sub 1 as a function of time with respect to time, plus the derivative of I sub 2 with respect to time would be equal to, again, di of t with respect to time. Now, at this point, although the inductance equation 3035 involves the rate of change of a current as opposed to the actual current itself, the conditions that lead to equation 3035 also led to the parallel resistor formula. This parallel resistor formula also applies to conductors. So you're going to add the inductance just as you would the parallel resistance or resistors in parallel. So we can say that 1 over the equivalent inductance would be equal to 1 over the inductance sub 1 plus 1 over, let's write it a little bit smaller, 1 over the inductance sub 1 plus 1 over the inductance sub 2. So essentially, this is how we would prove it. It's adding, we could say finding LQ is similar to adding parallel resistors. And we can, just to note, to ensure the independence rather of the voltage values, it is important that the inductors themselves are not too close together. So the requirement is that the field of one inductor not to have a significant influence on the other conductor. So essentially, the distance between the first inductor and the second inductor, and the second inductor and the third inductor, and so on, their distance can't be too close because then they would affect each other. For part B, just as using the same method as adding parallel resistors, we could say that for part B, 1 over the equivalent inductance would be equal to the sum n sub 1 to n of 1 over the inductance sub n. So this would be our answer for part B. That is the end of the solution. Thank you for watching.